Hello my dear students, welcome to VR Mathematics Academy. Myself Dr. Vivek Rohira, and today we are going to start logarithm, which is very useful in the basics of class 11th. Also it is very important in the JEE main, JEE advanced and in many calculations of physics and chemistry. Okay, so let me start logarithm. So today we are going to start the introduction of logarithm. What is logarithm? Why we are going to study the logarithm? So before starting the logarithm, firstly you should know about the indices or power or exponent. What is the meaning of exponent, power and indices? Okay, this is the topic of class 9th. Okay, so firstly we will take some examples. In examples, 10 square you will see equal to 100, 10 raised to the power 3 is equals to 1000 and 2 raised to the power 4 will be equal to 16. So here 2, 3 and 4, these are called exponent or powers. Okay, so firstly we should know what is the exponent and power. After that, in 2 raised to the power is equals to 16. This 2 is called base and the 4 is called exponent. If the base is negative, that is if we are taking the base minus 16 and we have applied the exponent 0.5, so we got a complex number. So base always should be a positive real number other than 1. This is very important. Base always should be a positive real number other than 1. Why? Because when we will find the exponent of 1, that is 1 raised to the power x is equals to 1, where x can take any real value, so it will always equal to a constant. Okay, so that's why we ignore the 1 and take every positive real number as a base. So we can define exponents and we can apply the properties of exponents very easily. So in journal we conclude that a raised to the power x is equals to n is the journal form of an exponent where small a is the base, which is positive real number other than 1, that is a should not be equal to 1, and the exponent x is any real value and somewhere it can be written as a rational value, and we find that the capital N, that is the result, the capital N will be greater than 0. So I think firstly we should know first basic what is the exponent or power, what are the condition of the exponent when we are applying on any base, and the base always should be a positive real number other than 1. Okay, so we understand very clearly about the exponent or power of indices. So our next topic is why do we study logarithm? So there was two scientists, John Napier and Henry Bridge, which they developed the logarithm. Number one, for replacing multiplication with addition. When we multiply the large numbers, so it will be more typical calculation. So to make it easier and convert or replace multiplication with the addition, they developed the logarithm. Number second, replacing division with the subtraction, so they developed the logarithm. Sometimes we have to find the number of digits in 2 raised to the power 18, so we apply the logarithm to find the number of digits. The next is when we have equation, some type of equation like 2 multiplied by square root of 3 with power x will be equal to 1728, and we have to find the value of x. So solving this type of question, we apply the logarithm and we can easily find the value of x. So that's why we are going to study the logarithm. Next, what is logarithm? So logarithm is the inverse operation of the exponential. Whatever the exponent we have studied, that is a raised to the power x is equals to n. If we find the inverse of this operation, so we got the logarithm. Or we can say logarithm of a given number is to given base. Logarithm of a given number, example that if we are taking a raised to the power x is equals to n, So we can say that logarithm of a given number, that is n log of n, with is to given a base, that is a small a, to which base must be raised in order to produce the number, that is equal to x. So whenever we find the log of n with the same base a, then it will be equal to the exponent of the base. So this is the logarithm. If a raised to the power x is equals to n, then we can say that log of base a of the number capital N will be equal to x. In both exponent and logarithm, we can found that they both have the same base, small a. Okay, and the condition of the base is a always greater than equal to 0 and a should not be equal to 1. The next one, we found that number capital N should always greater than 0. Then we found that the result of log n with base a will be equal to x, where x is real number. So this is, we find a correspondence relation between the exponent and radical. That is, if a raised to the power x is equals to n, then with the same base, logarithm of number n will be equal to the x, which is the exponent of the base, where this x is real number. Now we take this correspondence of exponent and logarithm and we find some result. So the first result, a raised to the power 0 will be equal to 1, we know. Then by the definition of logarithm, we can find that log of 1 with the same base will be equal to 0 by the definition. As earlier we studied the definition, a raised to the power x is equals to n, then log of the number with the same base will be equal to x, exponent. So the log of 1 will be equal to 0 with base a. The second property, we know about the exponent, a raised to the power 1 always equal to a. So the log of a with the same base will be equal to 1. So the meaning is that when we are finding the logarithm of a number with the same base, then the result always will be equal to 1. Third one, in the bracket a raised to the power n will be equal to a raised to the power n. When we will apply the definition of logarithm, so we found that log of a raised to the power n with the same base will be equal to n. This is very important result. We will use to solve many problems by this important results. So we understand some of the basic important results about the exponent and logarithm. So we understand that how the basics result about the exponent we correlate with the logarithm. So now we start some problems to understand this concept more clearly. So let me start. The question number 1, find the value of log of 81 with base 9. So here we found that in the solution, log of 9, 81 can be written as 9 square. So using the result, log of base a with a raised to the power n will be equal to n. So it will be equal to 2. So the answer of log 81 base 9 will be equal to 2. It's very easy. Question number 2, find the value of log base root 2 plus root 3 of 5 plus 2 root 6. We should know that log of base root 2 plus root 3, now log of that number 5 plus 2 root 6. 5 plus 2 root 6 can be written in the form of root 2 plus root 3 whole square. So again by the same property we can apply, and we found that it will be equal to 2. So we found that it is very easy to apply the result of logarithm. We can find some such type of problems. The next question, we have to find the x if log base 9x is equal to 2.5. So by the definition, we know that if a raised to the power x will be equal to n, then we found that log of n with base a will be equal to x. So we will change the logarithm in the form of exponent. So we found that 9 raised to the power 2.5 will be equal to x. So we found that it can be written as 9 square into 9 raised to the power half is equals to x. 9 square, that is 81, 9 raised to the power half, that is 3, will be equal to x. So the value of x will be equal to 243. So we can easily find the value of x by the help of the definition of logarithm. In question number 4, we have to find the x if 10 raised to the power 2x minus 1 is equal to 17 of the logarithm. When we will apply the same definition of logarithm, we will find that log of 17 with base 10 will be equal to 2x minus 1. So the 2x will be equal to 1 plus log 17 base 10, implies that x will be equal to 1 plus log 17 base 10 over 2. This is the value of x. So I think till now you understanding every concept of the logarithm, that is how we are applying the concept of logarithm to find the such values. So the next question is, we have to find the value of log base 5 into log base 2 into log base 3 into log base 2 512. In this type of question, we should know firstly that is 512 with the prime factorization can be written as 2 raised to the power 9. So when we will write it 2 raised to the power 9, then we first solve log base 2 512. So it can be written as log base 2 raised to the power 9. Then we found that by the result it will be equal to 9. Now the next we are taking log base 3 and this whole result will be equal to 9, and this is can be written as log 3 square, so it will be equal to 2. Then when it will be equal to 2, so now we will take log of base 2 of 2, then the logarithm of the number with the same base will be equal to 1. In the last we found that log of base 5 with 1, so log of 1 with base 5 will be equal to 0 because log of 1 0 with any base. So we found that the whole result will be equal to 0. So we find the value of this expression and we found that this is equal to 0. Okay, so now you understand the basic introduction of logarithm, that is how we are going to apply the logarithm and how we are applying this results and the basic definition of logarithm in such type of problems. So now check your level of doing such type of problems related to the same concept and write down your answer in the comment section. So for the next lecture of the logarithm, stay connected with my YouTube channel, and thanks to all of you my dear students. Hello my dear students, welcome to VR Mathematics Academy, and today I will introduce you about the laws related to logarithm. In the previous lecture you have studied about the concept of logarithm, that is the introduction of logarithm, and in this lecture we studied about the laws related to logarithm, that is how do laws help to solve the different types of problems based on logarithm. So let me start. The law 1, for xy greater than 0, log xy with base a will be equal to log x plus log y with the same base a. Every law we can prove with the help of exponents laws. Okay, so let's see how we will prove this law. For proving this law, x is equal to a raised to the power alpha and y is equal to a raised to the power beta. Then we can write down xy is equals to a raised to the power alpha plus beta. When xy is equals to a raised to the power alpha plus beta, now we can apply the definition of logarithm. So according to the definition of logarithm, log of xy with base a will be equal to alpha plus beta. So now what is the alpha? The alpha we can write down as log x with base a, and beta we can write down as log y with base a. So this is the first law we have proved. In the journal, the first law can be written as log of x1 into x2 into x3 up to xn is equal to log of x1 plus log of x2 up to log of xn. According to law second, log of x over y will be equal to log x minus log y. This can be also proved as we have proved law 1. For proving the second law, we will also take x is equals to a raised to the power alpha, y is equals to a raised to the power beta. Now x over y is equals to a raised to the power over a raised to the power beta. Then it can be written as a raised to the power alpha minus beta. Now by applying the definition of logarithm, log of x over y with base a will be equal to alpha minus beta, where alpha is equal to log x base a and beta is equal to log y base a. So this is we have proved law 2. Now the law third, for xy greater than 0, log of x raised to the power y is equals to y multiplication of log x with base a. That is, the power will multiply with the log of x. How we will prove this law? For proving that law, we will assume log x base a will be equal to alpha. So by the definition of logarithm to exponent, it can be written as a raised to the power alpha is equals to x. Now we apply the power y both sides. So it will be a raised to the power alpha power y is equals to x raised to the power y, and can be written as a raised to the power alpha y is equals to x raised to the power y. Now taking log on both sides, so when you will take log on both sides, then you will got log of x raised to the power y is equals to log of a raised to the power alpha y. That is, log of x raised to the power y is equal to alpha into y, and we can put the value of alpha, so we will got y into log of x with base a. So this is the proof of law third. So we have studied about the proof of law 1, law 2 and law 3. Now the next is law fourth, that is, log of x with base a raised to the power b will be equal to 1 over b multiplication of log x. This law also can be proved very easily. For that, what we will do, we just put log a raised to the power b will be equal to alpha. When we will put equal to alpha, then by the definition it can be written as a raised to the power b power alpha will be equal to x. Okay, or we can write down as a raised to the power b into alpha is equal to x. Now b alpha will be equal to log x base a. So alpha can be written as 1 over b log of x base a. And what is alpha? Alpha is nothing but it is log x a raised to the power b. So we prove that log x base a raised to the power b will be equal to 1 over b multiplication of log x base a. The law fifth, that is, log of y with base x will be equal to 1 over log of x base y. That is, base and number will interchange when we will write down it is in reciprocal. So when we will reciprocal of any logarithm, so its number and base will change. So now how we will prove that? So we can also prove that very easily. We will put log y base x is equal to alpha. Then by the definition, x raised to the power alpha is equals to y. Then x is equals to y raised to the power 1 over alpha, and log of x with base y will be equal to 1 over alpha. When we will take logarithm on both sides with base y, so it will be equal to 1 over alpha. 1 over alpha, that is 1 over log y with base x. So we can easily prove that log of y base x will be equal to log of y base x will be equal to 1 over log x with base y. Now the next one, law number 6, that is log of x raised to the power y with base a raised to the power b will be equal to y over x multiplication of log x base a. So this law 6th also can be proved easily as the law number 5th. The next one is law number 7th, which is very important, the change of base rule. In this law, we just change the base according to our requirement. Okay, as per our requirement, we can change the base very easily. So as per this rule, log of x base a can be written as log of x base b over log of a base b. So by this rule, we can easily understand the proof of this law. Let log x base a is equal to alpha, then a raised to the power alpha is equal to x. Now we will take logarithm on both sides with base b, that is log of base b a power alpha is equal to log of base b of x. Now we will apply the law 3rd. According to law 3rd, it will be alpha into log of a base b and will be equal to log of x base b. So alpha will be equal to log of x base b over log of a base b. Now what is alpha? Alpha is nothing but it is log x base a. So log x base a will be equal to log x base b over log a base b. So this is, we prove the change of base property. The next, law number 8, for a and n greater than 0 and a is not equal to 1, a raised to the power log of n with the same base a, with the same base, will be always equal to n. In this law, you can easily find that this is the base and this is the base of logarithm. They both are equal, small a. That's why the result will be equal to n. To proving this result, we will put log n base a is equal to alpha. Now a power alpha will be equal to n. If we will again put the value of alpha, then it will be a raised to the power log n base a will be equal to n. So I think law 8 is very easy to prove. Now the law number 9th, a raised to the power log base b of c is equal to c raised to the power log of a base b. That is, in this law we can understand that is the base and the number we can interchange. This is the base and this is the number for which we find the logarithm. We can change both of them, okay, as per the requirement. So now how we will prove this property? For that, we will assume a raised to the power log c base b will be equal to alpha. Now we can write down log of alpha base a will be equal to log of c base b. Now we will divide. Now we can write down it as log of alpha over log of a, and this can be written as log of c over log of b. We can cross multiply, so it will be log of alpha over log of c will be equal to log of a over log of b. So finally it can be written as log of alpha base c will be equal to log of a base b. So now by again apply the exponent definition it will be changed as c raised to the power log a base b will be equal to alpha. And what is alpha? Alpha is a raised to the power log c base b. So now we completely prove this law number 1 to law number 9. That is how we can prove these all the laws by the help of exponent properties. Now we start some of the problems based on these laws. So our question number 1, we have to evaluate log of 6 plus twice of log 5 plus log of 4 minus log of 3 and minus log of 2 with the same base 10. So in this question we can apply law 1, 2 and 3. According to applying all the laws, we firstly write down log 10 as it is. Now 6 multiplied by 2 log 5. So 2 is multiplying by log 5. So this 2 goes as a power of 5. So it will be 5 square, and already the sign plus, so they are going to multiply. Now plus log 4, so 4 is also multiply. Minus log 3, so 3 will be divide, and minus log 2, so 2 will be divide. Okay, so by this process now you can see that 3 and 2 cancel out by 6, and we will found that it will be equal to log base 10 of 100. So it can be written as log base 10 of 10 square, so will be equal to 2. So this is very easily we proved the question number 1 by the help of law 1, 2 and 3. In the next question, question number 2, we have to evaluate 7 log 16 over 15 plus 5 log 25 over 24 plus 3 log 81 over 80. In this question also we will apply law 1 and law number 3. According to that law, log of, we can write down, we will take 7 as a power, so it will be 16 raised to the power 7, 15 raised to the power 7 multiplied by 25 raised to the power 5, 24 raised to the power 5, 81 raised to the power 3 and 80 raised to the power 3. Now we can factorize. 16 can be written as 2 raised to the power 4, so it will be 2 raised to the power 28. 15 can be written as 5 into 3, so it can be written as 5 into 3 raised to the power 7. 25 can be written as 5 square, so it will be 5 raised to the power 10 over 24 can be written as 2 raised to the power 3 into 3 raised to the power 5. And 81 can be written as 3 raised to the power 4, so this will be 3 raised to the power 12. And 80 can be written as 2 raised to the power 4 into 5 raised to the power 3. Now we can check, that is it will be convert as logarithm of 2 raised to the power 28, 5 raised to the power 10, 3 raised to the power 12 over. Now in the denominator we can see that the exponent of 2 is 2 raised to the power 3 or 5. So the exponent of 2 is also 28, 15 plus 12 and 5 raised to the power also 10, and the 3 raised to the power we can write down as 12. So you can easily found that they all term will be cancelled out, and this is equal to log 1. The value of log 1 is 0. So the answer is 0. Next, question number 3, we have to evaluate log of 7. We have to evaluate log of base 7 into log of base 7 multiplied by the number square root of 7 square root of 7 square root of 7. So firstly we should know, that is we can write down this expression as log of base 7 log of base 7. Now this number can be written as 7 into 7 raised to the power half into 7 raised to the power 1 by 4 into 7 raised to the power 1 by 8. So this will be log base 7 and completely 7 exponent will be equal to 1 by 2 plus 1 by 4 plus 1 by 8. So finally we will found that this will be log base 7 7 raised to the power, and this will be 7 over 8. So now by the property we can write down as log, by the law we can write down as log base 7, and this will be by the law third we can write down 7 by 8 log of 7 base 7. So finally we write down log of base 7 of 7 by 8. Again we will apply law 2, and this will be written as log 7 base 7 minus log 8 base 7, and log 7 base 7 is 1, and it will be log 8 base 7. So we found the answer 1 minus log 8 base 7. This is the question number 3rd we have completed. In the question number 4th, we have to find the value of 6 raised to the power log of 40 with base 10 multiplied by 5 raised to the power log of 36 with base 10. So let's see how we will solve the problem. So firstly, we will write down as 6 log base 10, and 40 we will write down as 10 into 4 multiply by 5 log base 10 6 square. In the next step, 6 log of 10 into 4, so we will write down as log of 10 plus log of 4. So log of 10 will be equal to 1, plus it will be log of 4 with base 10 multiplied by, here we will apply the law number 3rd. By law number 3rd, power will be multiplied with the log of 6, so it will be 5 square log of 6 base 10. Now this can be written as 6 multiplied by 6 log 4 base 10, and this can be multiplied by 25 raised to the power log 6 base 10. Since we know that a raised to the power log c base b can be written as c of log a base b, so in the same way we can write down 6 into 6 raised to the power log 4 can be written as 4 of log 6 with base 10, and 25 log of 6 with base 10. So now this will be 6 into 4 into 25, because both have the same exponent, so log of 6 base 10, and 25 into 4 is 100. So this will be 6 into 100 can be written as 10 square log of 6 base 10, or it will be written as 6 into 10 raised to the power log of 36 base 10, because 6 square is 36. Now in this expression we can apply the property a raised to the power log of with the same base into n will be equal to n. This complete expression can be written as 6 into 36, that is the value will be equal to 216. So the value of 6 raised to the power log 40 into 5 raised to the power log 36 with the same base 10 will be equal to 216. In question number 5th, we have to find the value of 81 raised to the power 1 over log 3 base 5 plus 27 raised to the power log 36 base 9 plus 3 raised to the power 4 over log 9 base 7. So in this type of question, we will apply the property as 81 raised to the power 1 over log 3 base 5. So we will write down as log 5 base 3 by using the property log of x base y can be written as 1 over log of y base x, plus 27 can be written as 3 raised to the power 3, and log of 36 base 9 can be written as 3 square and 6 square plus 3 power 4 multiplied by log 7 base 9. Now we will apply the property here, log of a raised to the power b x raised to the power y will be equal to y over b log of x base a. So now this expression can be written as 81 we will write down as 3 raised to the power 4 log of 5 base 3, and this can be written as 3 raised to the power 3 into log of 6 base 3 and plus 3 raised to the power 4 by 2 log of 7 base 3 by using these properties. Finally, we will write down 3 raised to the power log base 3 into 5 raised to the power 4 plus 3 raised to the power log base 3 6 whole cube plus 3 raised to the power log 7 square base 3. Now in all the expression we can apply the property a raised to the power log base a into n, that will be n. So it will be equal to 5 raised to the power 4, it will be equal to 6 raised to the power 3 and it will be equal to 7 square. So 5 raised to the power 4 will be equal to 625, 6 raised to the power 3 will be equal to 216 and 7 square will be equal to 49. So finally it will be equal to 890. So this is our question number 5th. In question number 6 we have to find the value of log 4 base 3 into log 5 base 4 into log 6 base 5 into log 7 base 6 into log 8 base 7 and into log 9 base 8. So in this type of question we can apply the property log x base y will be equal to 1 over log y with base x. So it can be written as log x base y multiplied by log y base x will be equal to 1, because of we found that this x and x cancel out and finally log of y with base y will be equal to 1. So same we can apply in this question. In this question we have to given log of 4 base 3 multiplied by log of 5 base 4 multiplied by log of 6 base 5 multiplied by log of 7 base 6 and multiplied by log of 8 base 7 and multiplied by log of 9 base 8. So here you can found the pattern that according to that property you can found the pattern that this 4 and 4 cancel out, 5 and 5, 6 and 6, 7 and 7, 8 and 8 cancel out. Finally we have only the term log base 3 of 9 and log base 3 of 9 can be written as log of base 3 of 3 square, which will be equal to 2. After understanding all the laws related to logarithm with its proof, how we will apply these all the laws in different types of problems. So hello students, welcome to VR Mathematics Academy, and today I will introduce you about the logarithmic equations. So far we have studied about the logarithmic introduction, we have studied the laws of logarithm. Here we use the laws of logarithm and logarithm definition to solve the logarithmic equation. So let we start. Equations involving logarithmic terms is called logarithmic equation. So firstly we should know what is the meaning of logarithmic equations. Now examples: log of x square minus 1 with base 2 is equals to 3. This is logarithmic equation. Log of 9 base 2 minus 2 raised to the power x is equal to 3 minus x. This is also logarithmic equation. Now to solve logarithmic equation we use laws of logarithm and its definition, which we have already studied. Also we ignore those solutions which do not satisfy some of the terms of original equation. Also we should know about the domain of original equation. So whenever we solve logarithmic equation, we ignore all those solutions which do not satisfy the some of the terms of original equation. Also we should know about the domain of original equation. Now we start some of the problems. So our question number 1, we have to solve log of 4 minus x base 9 is equals to 0.5. So for that solution we apply the definition of logarithm. We change it into the exponent form, that is 9 raised to the power 0.5 will be equal to 4 minus x. implies that 4 minus x, that is the square root of 9 is 3, implies that x will be equal to 4 minus 3. So that's why the value of x is equal to 1. So this is the solution of equation log of 4 minus x base 9 is equal to 0.5. Here we can already see that 4 minus x greater than equal to 0, 4 minus x greater than 0 implies that x should be less than 4. So x is equals to 1 satisfy this condition. So this is our solution. The next question, question number 2, solve log of x minus 1 base 10 minus log of x minus 9 base 10. Here in this question we can found that now this question can be written as log of x base 10 plus log of x minus 9 base 10 will be equal to 1. Now we apply the law log m plus log n, so it will be log m into n with base 10 is equal to 1. So now it can be written as 9x minus x square will be equal to 10 raised to the power 1. X square minus 9x minus 10 will be equal to 0. So when we will solve this equation, so the factor will be x minus 10 into x plus 1 will be equal to 0, implies that x will be equal to 10 and x will be equal to minus 1. Now we know that for this equation x will be greater than 0 and x minus 9 also greater than 0, that is x greater than 9. So x greater than 0 and x greater than 9, that is the common is x greater than 9. So we can check x is equals to 10 and x is equals to minus 1, which satisfy this condition. So we found that x is equal to 10 is satisfy the condition of this domain. So x is equals to 10 will be the solution of the equation. Also we can easily define that when we put x is equals to minus 1 in the term log of x base 10, so x is equals to minus 1 does not satisfy this term because we know that x should be greater than 0. So by using this condition we can found that x is equals to 10. Also we can found that x is equals to minus 1 not satisfying this term. So the solution of this equation is x is equals to 10. The next question number 3rd, we have to solve log of minus x is equal to twice of log x plus 1. So in this question we know that minus x should be greater than 0, implies that x should be less than 0. Also x plus 1 should be greater than 0, that is x greater than minus 1. So we found that x less than 0 and x should be greater than minus 1. So now we solve this equation. So we can write down log of minus x is equal to log of x plus 1 whole square, implies that minus x will be equal to x plus 1 whole square. When we will solve this, so it will be x square plus 3x plus 1 is equal to 0. So now when we will solve x square plus 3x plus 1 is equals to 0 by Sri Dharacharya formula, then it can be written as minus 3 plus minus root of 5 by 2. But we know that x less than 0 and x greater than minus 1. So the value of x minus 3 plus root 5 over 2 will be only the solution of this equation because it satisfied this domain value x less than 0 and x greater than minus 1. So I think you understand how we will find the solution, how we are using the concept of domain. Next, question number 4th, we have to solve log of base x square plus 6x plus 8 into log of base 2x square plus 2x plus 3 of x square minus 2x is equal to 0. Now in this question, when we will find the solution, the first condition should be, that is, this whole term should be equal to 1, that is log of x square minus 2x base of 2x square plus 2x plus 3 should be equal to 1. Then log of this term will be equal to 0. So we take this concept. So we will take this concept, log of x square minus 2x with base 2x square plus 2x plus 3 will be equal to 1. Now we change it into the exponent form. So it will be 2x square plus 2x plus 3 will be equal to x square minus 2x. Then now we rearrange the terms. So when we will rearrange the terms, so it will be x square plus 4x plus 3 will be equal to 0. So the value of x will be equal to minus 1 and minus 3. These are the values of x. But we know that when we will put x is equals to minus 3 in the base x square plus 6x plus 8, so it will be 9 minus 18 plus 8, which will be less than 0. And we know that the base, that is small a, always greater than 0 and not equal to 1. So x is equals to minus 3 does not satisfy. That's why x will be equal to minus 1 is only the solution of this equation. I think very clearly you understand this solution. Again, so the next question we move. Question number 5th. Solve 4 raised to the power log of log x with base 2 is equal to log x minus log of x whole square plus 1. Now we know that this equation will be meaningful when x greater than 1. Why? Because if x is equals to 1, then log of x will be equal to 0. And when log of x will be equal to 0, then we know that log 0 will be equal to minus infinity. Okay, so that's why we will not take x is equal to 1. Okay, we will not take x is equal to 1. And also when we will take x is equals to 1, it will not satisfy the system. That's why we are taking x greater than 1. Because 4 raised to the power minus infinity, it will also become 0, and 0 will be equal to 1, which is totally meaningless. So we are taking x greater than 1 to make it meaningful. Now we know that log 4 raised to the power log 2 log x can be written as 2 raised to the power 2 log base 2 of log x, which further can be written as 2 raised to the power log base 2 log of x whole square. So this particular term can be written as in the form of log x whole square. Implies that log x whole square will be equal to log x minus log of x whole square plus 1. Now twice of log of x whole square minus log of x minus 1 will be equal to 0. By this quadratic equation, we will found that log of x will be equal to 1 or log of x will be equal to minus 1 by 2. Now for x greater than 1, since for x greater than 1, log of x will be greater than 0. That's why only we will take log of x is equal to 1 and we will ignore this solution. So when log of x is equal to 1, so x will be equal to e, because here we have taken the logarithm basis small e. So x is equals to small e will be the solution of this equation. In question number 6, we have to solve a square root of log x base 2 minus 0.5 is equal to log of root x base 2. Now in this question, we have started this question by taking a square root of log x base 2 minus 0.5. Now this root x can be written as 0.5, that is we will take the power in the multiplication of log x base 2. 1 by 2 we will take as a multiplication by the log, and 1 by 2 can be written in the form of 0.5. We will take a square root of log x base 2 will be equal to capital X. Then it will be x minus 0.5. X minus 0.5 is equal to 0.5 x square. Finally, this equation can be written as x square minus 2x plus 1 will be equal to 0. So x square minus 2x plus 1 will be equal to 0. So this will be x minus 1 whole square is equal to 0. So capital X is equal to 1. That is square root of log x base 2 will be equal to 1, or log x base 2 will be equal to 1. So by this we can found that x should be equal to 2. X should be equal to 2, which satisfy the domain of this equation also. Next, question number 7. In question number 7, we have to solve the equation x raised to the power log of 2x with base root x is equal to 4. So now when we will solve this equation, so we should know firstly that x should be greater than 0 and x should not be equal to 1. Okay, so now we will solve this because x is like a base and base always greater than 0 and not equal to 1. So now by this theory we just solve this. So we found that it will be x raised to the power twice of log 2x base x will be equal to 4. Now this 2 we will take as a power, so it will be x raised to the power log 2x whole square base x will be equal to 4, and by the law it can be written as 2x whole square is equal to 4, implies that x should be equal to plus minus 1. When x will be equal to plus minus 1, so in the starting we already found that x is not equal to 1, and also why we are not taking x is equals to minus 1, because of 2x should be greater than 0, that is x should be greater than 0. So when x should be greater than 0, then x is also not equal to minus 1. So when x is not equal to 1 and x is not equal to minus 1, implies that this equation has no solution. The equation has no solution. Okay, so far we have done this question also. Now we move to the next question, question number 8. That is, we have to solve x raised to the power log of 1 minus x whole square base x is equal to 9. In this equation, we found that again x is like a base, so x should be greater than 0 and x should not be equal to 1. Also 1 minus x whole square greater than 0. Also 1 minus x whole square greater than 0. Now by taking logarithm on both sides, so when we will take logarithm on both sides, so it will be log of base x 1 minus x whole square will be equal to log of 9 base x, and log of 9 base x can be written as 3 square, so it can be written as twice of log 3 base x. Now we can write down this equation as log base x 1 minus x whole square over log 3 base x will be equal to 2. Now by the law we can write down as, by the law change of base, we can write down it as log of 1 minus x whole square base 3 will be equal to 2, implies that 1 minus x whole square will be equal to 9. 1 minus x whole square will be equal to 9, implies that 1 minus x will be equal to plus minus 3. 1 minus x will be equal to plus minus 3. So x will be equal to 4 or x will be equal to minus 2. But x greater than 0, so that's why we will take x will be equal to 4. We ignored the value x is equal to minus 2. So the solution of this equation is x is equal to 4. In the next question, we have to solve x raised to the power root x is equal to root x raised to the power x. Taking logarithm on both sides, we will find that root x multiplied by log x will be equal to x multiplied by log root x. Implies that log x we will take common and it will be root x minus x by 2 will be equal to 0. Now we know that now either log x is equals to 0 or root x minus x by 2 will be equal to 0. When log x is equals to 0, then x will be equal to 1, and when root x minus x by 2 is equal to 0, then it can be written as x is equal to x square by 4, or 4x minus x square will be equal to 0. We will take x common, then it will be 4 minus x is equals to 0. So we found that x will be equal to 4 and x should not be equal to 0. X should not be equal to 0 because already we found that. So we found that solution of this equation will be x is equals to 1 or x will be equal to 4. So far we understand that is how we solve the logarithmic equation. So I think you understand the concept of logarithmic equations. So solving the logarithmic equation, we use the laws of logarithm, we use the definition of logarithm, we use the domain of the logarithm, then we can easily solve the logarithmic equations. Logarithmic inequality. So before start about the logarithmic inequality, you should know about logarithmic definition, logarithmic laws, inequality concept, okay, then modulus concept. Then you can easily understand about the logarithmic inequality. So we should know some of the standard logarithmic inequalities. The number 1, when log x base a greater than log y base a, then it will be x greater than y when base is greater than 1, and it will be x less than y when base less than 1 greater than 0. In the similar way, second one is log x with base a greater than y will be equal to x greater than a raised to the power y when base greater than 1, and when base less than 1 greater than 0, then it will be x less than a raised to the power y. The third one, when log x base a greater than 0, then x will be greater than 1 when base greater than 1, and x will be less than 1 greater than 0 when base is less than 1 greater than 0. Number 4th, when log of fx base gx greater than 0, then obviously fx will be greater than 1 when base gx will be greater than 1, and fx between 0 to 1 when base gx will be between 0 to 1. Fifth standard logarithmic inequality is log of fx base gx less than 0, then fx will be greater than 1 when base will be between 0 to 1, and fx will be between 0 to 1 when base greater than 1. The number 6, log of fx greater than log of gx with base hx. will be equal to fx greater than gx and gx greater than 0 when hx greater than 1 and fx less than gx and fx greater than 0 when hx less than 1 greater than 0. So these are some standard logarithmic inequalities. By the help of these, we easily solve some of the problems. So let we start some of the problems. So our question number 1, solve log x minus 2 base 3 less than equal to 2. So we have to solve log x minus 2 base 3 less than equal to 2. Here we know that base a is equal to 3, which is greater than 1. So when base is greater than 1, then we can write down that is x minus 2 will be less than equal to 3 square by the standard logarithmic inequality concept, and it will be greater than 0. Okay, then x minus 2 less than equal to 9 and greater than 0. Then we can found that x will be less than equal to 11 and greater than 2. So this is the solution of this inequality. In the question number 2, we have to solve log of mod of x minus 3 base 0.2 greater than equal to 0. Since we have to given the base 0.2 which is less than 1 greater than 0, then by the logarithmic inequality concept, mod of x minus 3 will be less than equal to 0.2 raised to the power 0, that is 1, and it will be greater than 0, that is mod of x minus 3 less than equal to 1 and greater than 0. When mod of x minus 3 greater than 0 implies that x minus 3 should not be equal to 0, and mod of x minus 3 less than equal to 1, then by inequality concept we can found that x minus 3 will be equal to less than equal to 1 and greater than equal to minus 1. So x will be less than equal to 4 and greater than equal to 2, and x should not be equal to 3. So we can found that x belongs to close interval 2 to 4 minus 3. So this is the solution of question number 2. Okay, so next question number 3, we have to solve log of x minus 1 base 0.4 greater than equal to log of x minus 1 base 0.2. So in this question, we firstly equalize the base on both sides. So log of 0.4 can be written as 1 by 2 log of 0.2 x minus 1 greater than equal to log of 0.2 x minus 1. Now this can be written as log of 0.2 x minus 1 greater than equal to log of 0.2 x minus 1 whole square, but here we have to given the base is 0.2 which is less than 1 and greater than 0. So that's why x minus 1 will be less than equal to x minus 1 whole square. So when x minus 1 less than equal to x minus 1 whole square, then it can be written as x minus 1, and in the bracket it will be minus x plus 2 less than equal to 0, or it will be x minus 1 into x minus 2 greater than equal to 0. So we can found that the x is lie between 1, 2, positive, negative, positive. So in this region the x will be lie. Okay, but we know that x minus 1 is also greater than 0, that is x should be greater than 1. So when x should be greater than 1, so the final answer we will found that, or common reason we will found that x greater than equal to 2. This will be solution of the question number 3. Question number 4. In the question number 4, we have to solve 2 plus log root x plus 1 base 2 greater than 1 minus log 1 by 2 square root of 4 minus x square. So before solving this one, we should know that x plus 1 greater than 0 and 4 minus x square also greater than 0. So it should be x greater than minus 1, and it should be x is between minus 2 to 2. That is, by both we found that x is between 2 to minus 1. Okay, this is firstly we should know. Now we rearrange the terms. By rearranging the terms, we got 1 plus log base 2 root of x plus 1 minus log base 2 square root of 4 minus x square greater than 0. And now this can be written as 1. 1 also can be written as log 2 base 2 plus log base 2 square root of x plus 1 minus log base 2 square root of 4 minus x square greater than 0, implies that it will be log base 2 twice of root x plus 1 over root 4 minus x square greater than 0. Okay, so it will be, because the base is greater than 1, then it can be written as twice of root x plus 1 over root 4 minus x square greater than 1. Okay, so this will be greater than 1. Write down these steps. Now we can find that twice of root x plus 1 greater than root 4 minus x square. So now when we squaring both sides, so it will be 4 into x plus 1 greater than 4 minus x square. That is, it will be x square plus 4x greater than 0. So we found that by this one. So x square plus 4x greater than 0, that is x into x plus 4 greater than 0. So we draw the number line minus 4 and 0, and this is positive and this is also positive. So the both area we will taken. Also we have to given that is x is between minus 1 to 2, minus 1 to 2. So we found that the final reason will be 0 to 2. That is, x is between 0 to 2. So x is between 0 to 2 will be the final solution of the question number 4. Next, in the question number 5th, we have to given log of x square minus x with base x plus 3 less than 1. Since in this question the base is variable, also the condition you should know. Also, if you will found the condition, that is x square minus x greater than 0, that is x into x minus 1 greater than 0. So we found that by the number line, this will be either greater than 1 or less than 0. So this is the condition we found. But now if we discuss about the base, so here the base is variable. So in the variable base we will take two cases. Case number 1, when the base is greater than 1. Case number 2, when base is less than 1 greater than 0. So when base greater than 1, then this will be x greater than minus 2. Okay, so in the case of base greater than 1, x square minus x will be less than x plus 3, and it will be x square minus 2x minus 3 less than 0. That is x minus 3 into x plus 1 less than 0. So by both condition x greater than minus 2, by condition x minus 3 into x plus 1 less than 0, and the initial condition, that is x into x minus 1 greater than 0, we found that x belongs to minus 1 to 0 union 1 to 3. This is the solution. But when we will take the second case, x plus 3 less than 1 greater than 0, that is, in that case x will be less than minus 2 and greater than minus 3. So in that case x square minus x will be greater than x plus 3. So it will be x square minus 2x minus 3 greater than 0. That is x minus 3 into x plus 1 greater than 0. So now by the condition x is between -3 to -2 by the condition x minus 3 into x plus 1 greater than 0, and by the initial condition we found that x belongs to -3 to -2. This is the common reason. So in the case first, the solution is this one. In the case second, this one will be the solution. So this is the solution of question number 5th. So when base is variable, so we have these type of solutions. So we can divide the solution into two categories. One when the base is greater than 1, and one of when the base is less than 1 greater than 0. Next, in the question number 6. So in the question number 6, we can also found that here also we have to the given base. Okay, we will take also the two condition. So here we can also take the two condition. This base is greater than 0 and this base is not equal to 1. So now when base is greater than 0, when we will take, then we will take two condition. One of when base is greater than 1, the second one is when base is less than 1 greater than 0. In the first case, x should be greater than 3. In the second case, x should be between 3 to 2. So in the first case, we found that x square minus 6x plus 8 should be greater than 0. That is x minus 2 into x minus 4 greater than 0. That is x less than 2 and x greater than 4. Okay, but x is greater than 3. So that's why the final solution will be x greater than 4. In the second case, x square minus 6x plus 8 less than 0. The meaning is that x is less than 4 greater than 2. But when x is less than 4 greater than 2, and by the given condition between 2 to 3 solution, x is between 2 to 4. So by both the condition we can found that x will be greater than 2 and less than 3. So now the common solution is x is between 2 to 3 and union 4 to infinite is the complete solution of this question number 6. Now in the question number 7, we have to find the value of x for which the function is defined. So we know that function will be defined when log base 1 by 2 x minus 1 over x plus 5 greater than equal to 0. So when this will be greater than equal to 0, because the base is less than 1 greater than 0, so x minus 1 over x plus 5 will be less than equal to 1 and greater than 0. So when x minus 1 over x plus 5 greater than 0, so in that case we will found that the critical point will be minus 5 and 1, and this will be the reason x less than minus 5 and x greater than 1. But when we will take x minus 1 over x plus 5 less than equal to 1 and x minus 1 over x plus 5 minus 1 less than equal to 0, so we will found that minus 6 over x plus 5 less than equal to 0. By this we conclude that x should be greater than minus 5. So when x should be greater than minus 5, so by both we can found that x belongs to open interval 1 to infinity. This is the solution of question number 7. So far you will found that how we will solve the logarithmic inequalities.